So, welcome to OFCM 2022 G4 session 4. Welcome to the G4 participants as well as audiences who are watching YouTube streaming session. I welcome all of you. So let's start this session. Okay, let's start with the revision question. Okay. So how many of you have done associative property of addition under real numbers? In fact, I asked you to do during the class associative property of real numbers. In the last class, I have asked you to discuss during discussion time. Okay, if not during last discussion, now you can do. What is the associative property of real numbers under addition? Think about this. You got to think in terms of, okay, quantifiers. Is there a quantifier? If so, how many? Then can you formulate the statement? I think Divya, you have to make me co-host. I couldn't see the number.
Yes, sir.
Or 15, yes.
Oh, so far. Very less. Quick. Asking easy question. Associative property of real numbers. Now I could see. 20, 21. Yeah, quick. 20 seconds. Very good. Somebody from R5.
Shweta. Shweta.
So addition property, sir.
Yeah, exactly. Under addition.
A plus B plus C is
Come on.
equal. Sir?
See, this is very bad. This is session 4 now. Okay. You have to understand the question, react accordingly. What was my question? That you have not listened carefully. My question was, first of all, look at the associative property under addition. Think about the statement carefully. Is there a quantifier? Think about it. If so, then how many quantifiers? Then formulate the statement properly with the quantifiers. Are you listening?
Yes, sir. Just now I joined, sir, so I don't.
That's what. That's a problem. You should have told before. Give me another 10 seconds, I would have given you. Right? Yeah,
Yes,
now
sir.
can you tell? In fact, it's better to join 10 minutes before.
Sorry,
Divya
sir.
instructed that day, no? Right. It's okay. So hereafter make a point.
Yes,
Yeah,
sir.
can you give the statement? What is there a quantifier first? Answer that question.
Yes, sir. There is a quantifier.
Which quantifier?
Real number. Associative property, sir.
Now for that, which quantifier?
Real numbers.
Quantifier, I am not asking the underlying set. I am asking the quantifier. How many quantifiers are there? Okay. I think you have not done that day carefully. Let me ask, let's go to R7.
Soumya.
For all
Very good. You can start. Very good. For all.
A, B, C belongs to real numbers.
Very good.
A plus B plus C is equal to A plus B plus C.
Very good. A plus B plus C. The way in which you read, it says I should put the bracket like this. That's fantastic. Right? Okay. Very good. Fantastic. Okay. Now I'm clearing all the feedback. Yeah, as usual. Quick, 20 seconds time. You know what I'm going to ask, right? Should I tell? Negation. Okay, quick. R9. Still, I could see only very less response. Why? 35,
Govendran,
56 today, very less.
there exists A,
very,
B, C belongs to R.
very good.
A plus B plus C is not equal to A plus B plus C, sir.
Excellent. Fantastic. Very good. That's all. Think, concentrate. Okay, you'll be able to say what it is. Right. Very good. Let's formulate some. Okay. Now let's even look at the identity property. I'm going to clear. Okay, all your feedback. Now let's look at the identity property. What is the additive identity? All of us know it is 0. Okay. What does the proper 0 has? Okay. So if you look at the identity property carefully, can you answer how many quantifiers are there in the identity property? Okay. Just for fun, I'm asking this question. If you don't get, doesn't matter at all. See, this is thinking ahead of teacher, right? How many properties, how many quantifiers are going to come? Quick. Those who can think now. Very good. R1, Jayashree.
So there are 2 quantifiers.
Fantastic. Can you say the statement itself?
Yes, sir.
Good.
There exists 0. 0
Good.
belongs to R. For all A belongs to R.
With property. What
plus
property?
0.
0 acts as an identity. That means, yeah, for
For
all,
all
A belongs,
A belongs to A plus 0 equal to 0 plus A equal to A.
Very good. A plus 0. Let's keep simple statement, okay? A plus 0 equal to A. Is that okay?
Yes,
We have
sir.
discussed already commutative. Therefore, A plus 0 is going to be equal to 0 plus A. Okay? That also we'll do later. Okay, now see, look at this statement. This statement has 2 quantifiers. What does it say? Please understand the statement carefully. There is, in the set of real numbers, I can find a real number called 0. Okay, there is a real number 0 with some special property. What is the property? Give me any real number A plus 0 is same as A. Okay, adding with 0 doesn't change the identity of A. Okay, it doesn't change A. Therefore, identity of A is kept as it is. A is itself. Have you understood? Okay, fantastic. See, you have to fully understand. Okay, anyway. Right? Whether all of you have understood the statement, quick response. 10 seconds. That question is going to retain only for 10 seconds. Quick response. Very good. But still, it's not reaching. Today, 50, it should touch. Only 43. Okay. I'm clearing all your feedback. Yeah, all of you know I'm expecting negation. Let's go slow and negate. See, once it's written in the symbolic form, it's easy to negate. How do I do that? I have to do layer by layer. That's why we are putting brackets. Okay. So you think at the same time, look at the explanation. Okay. It's good. Maybe this is the first time all of you have thought about it. I'm not going to ask one of you. I'm going to explain myself. Before that, just go through what is going to come. Fine. Very good. So let me explain. Yeah. See, there is a 0 in R. It says I can find an element 0. If it is false, then what should I have? This is the first layer. There exists 0 in R. Whatever I have written in this one, yellow colored bracket is the property for this. Then white color. Have you understood? There exists 0 in R with property written in white color, bracket written. See, if the statement is false, then what should happen? Given 0 in R, given an element 0 in R, any element, okay, call it as 0, doesn't matter. Okay, whatever written in the yellow bracket should be false. Whether all of you follow this? I'm clearing the feedback. Have you followed my words? Very good. So whatever written in the yellow bracket is false. So I have to negate whatever I have written in the yellow bracket. Whether all of you have understood this? Yes. So what is the negation? So let's again write an yellow bracket and write what we want. What is that? This I have to negate. Again, see, it is made up of 2 brackets. Okay. Right. But here what it says, this says, given any element of R, whatever written in the white bracket is true. If it is wrong, that means what? I can find a member of A for which this property is false. Okay. So I have to negate this statement. Is that clear to all of you? Again, I am clearing the feedback. Very good. Okay. I'm going to ask one of you. Let's ask R3. Somebody from R3.
Uday Chandrika.
There exists A belongs to R.
Fantastic. With what property?
A plus 0 not equal to A.
Very good. Okay, this is what I right. So it could be very nested thing. So we can make it. I hope all of you have understood. We will do a lot of exercises. Okay, I'll clear the feedback. Okay. Let's do a plain English statement. Okay. Okay. There is a tree. There is a tree in the campus which every leaf is brown. Brown in color. Whether all of you have understood the statement? Yeah. Now what is that? We have to write this statement. This is plain English statement. ES I will call it. English statement. Now I have to write the statement in symbolic form. Or SC. Statement. Okay. In English form SC. Statement in symbolic form SS. Okay. Right. So before writing SS, I have to invent notation. So what is the notation I have to do? I have to look at the underlying set. Okay. So when underlying set and all will come, I have to look at quantifiers. So is there a quantifier? If so, how many quantifiers? So that's the first question. Find out whether the statement have quantifiers. Okay. If so, how many quantifiers? And say it in that order. Yeah, I'm waiting for your response. Again, 30 seconds only. Still push up only. See, lot of people are not answering. R2, Sherin, Sanjana has answered, but still now only people are answering. Look at Nandini Shri, Dhanraj Prasanna, Kritika Kriti, Kirti, Agatya Lakshmi. Okay. You ask somebody from R4.
Maharshi.
Sir, two quantifier
Very good.
there exist and for all.
In that order, right? Very good. Excellent. There are two quantifiers, there exists and for all. Okay. I'm clearing all the feedback. So there are two quantifiers. One is there exists and other is for all. So for each of these coordinates will have an underlying set. Okay. First we'll write the underlying set for there exists. Okay. Can you find out the underlying set for there exists? Quick. Very good. So somebody from R8.
Haripriya.
Tree, sir.
Don't say tree. Tree is one single element. I want set.
Set of tree.
So we'll call it with capital T. Don't say set of trees. Set of trees where? In West Bengal or in Punjab? Set of trees where? You have to be very precise. Set of trees. Look at the statement carefully. In the campus. It's about a particular campus. Set of trees in the campus. Very good. So T we call set of trees in the campus. We have identified the underlying set for there exists. Now we have to identify the underlying set for the quantifier for all. Okay. But now before identifying, look at the statement carefully. In fact, we can start writing even the statement, but we have to do carefully. Okay. Let me write the statement. Yes. We'll give a gap and write here. So now, how does it should start? For every small t in capital T, right? For every tree in set of trees in the campus, some property is there, right? Okay. Now we are going to write that property. Okay, what is the property? Look at the property. Okay, but is it for all? I'm sorry, I have made something wrong. So it is there exists, correct? There is a tree, and you have identified there exists correctly. Okay. Now, for the second quantifier is for every. So now I want to identify the underlying set for this. But what is the underlying set for the second quantifier? Please think about this question. I'm clearing the feedback. See, stay focused, then you will get it right. It's not that easy. You have to stay focused. Okay. I'll ask, I'm waiting for another 10 seconds. Quick. Let's ask someone from R6.
Radhika.
Sir.
Don't say, sir. Come up with the answer quickly.
Leaf brown.
No. Brown is property. You are not focused at all. Okay, somebody from the same group. Somebody else from the same group.
Sultana.
Sir, set of all leaves which in brown color.
That's not right, no. Being brown color is a property, no. Set of all leaves only you should say, okay.
Yes, sir.
See, that's the point. Property is brown. Being brown is property. Okay. Set of leaves of what? That's where I said be in focus. Okay. Can one of who else is ready for this question? Set of leaves of what? Still we have not written the underlying set. Okay. L I'm going to put, but set of leaves of what? Set of leaves of tree of the tree, what?
In the campus.
No, that's wrong. See, look at the statement. You are not imagining the statement at all. Let's draw a picture and make you understand. Okay. See, it's something like there are a lot of, okay. I'll draw using this green color. Okay. There are a lot of trees in the campus. Okay. Now, what does this statement says? Please understand the statement. There could be a lot of trees. What I'm trying to say, I can find a tree in which, okay, whatever leaf I'm going to take, okay, that's going to be in brown color. Any leaf I take, okay, it's going to be in brown color. So this is the tree I have identified. Do you understand? Okay, I should use this marker, but anyway, have you understood? So what is that I'm looking for? I'm looking for set of all leaves on the tree. See, how do we denote this tree? This tree could be T1. Okay, this could be T2. This could be T3. Or this could be tree small t. This could be tree smallest. Something, some notation we keep. Have you understood this? Let's keep T1. This is T1. This is T2. This is T3. Right? And I don't know whether I can count, is it counted properly and all. So I simply put set of leaves of what? Can anyone now answer quickly? It's a very quick thought. Just answer.
So set of all lists of the tree T.
Very good. That's fantastic. Yeah. So L. So therefore I should put that T is there, small t is there. Okay. So given T in T, what is LT? LT is set of leaves of the tree T, small t. Do you understand? The set itself has the index T. I am collecting all the leaves of the tree T. So this will be small t1, this will be small t2, this will be small t3. And what is LT1? LT1 will be set of leaves of this tree. What is LT2? LT2 will be set of leaves of this second tree. LT3 is going to be set of leaves of the third tree. Do you understand? I'm clearing the feedback. Okay. Take some time and respond the question. If you have understood, put yes. Otherwise, put no. If you have doubt, now itself ask. Very good. Soumika, can you come up?
Sir, please explain this again.
Explain again.
Yes, sir.
Okay, you can mute yourself. See, first you have to be in a place where you can listen. I think there is a, okay. I've already explained, but as you asked, I'm again explaining. Look at the statement. There is a tree in the campus in which every leaf is brown. Have you understood this statement?
Yes, sir.
So what is capital T? Capital T is set up for the first quantifier there exists. We have put capital T. That also you understood?
Yes, sir.
All right. Now, I want to have a notation for this. What is the underlying set for the second quantifier for all? But look at the statement. Okay, what does the statement say? There is a tree T, small t, with the property. What? Every leaf of that tree. So if this is small t, okay, what is LT? LT is set of leaves of the tree T. I have to collect that. Okay. Still, do you have a problem? Yeah, anyway, you keep your question
No, sir.
bit focused. If you have doubt, try to clear during the discussion time. If not, I will help you. Okay, you can call me. Okay, so therefore, how should I form? Okay, for every L in LT, I have a property. What is the property? Okay, I'm clearing the feedback. All of you be ready with the answer. I'm going to ask one of you. There exists T in T. Then given any leaf in LT. Okay. What is that I have to write inside this second bracket? Very good. Still, some people, you have to push yourself. Okay. R1. Somebody from R1. Jayapriya. Jayapriya.
Sir,
What should I write now?
property is brown in color.
Which one? Correct, right? I have written everything. There exists T in T for all L in LT. What is that I have to write now?
LT belongs to.
You are not focused at all. That's the problem. Okay. I will ask somebody from R3. Abhinaya, quick.
L has the property of being.
Abhinaya, can you come again?
L has the property of being.
Don't say L is brown. That's very good. L is brown. L has the property of being brown. It's simply write L is brown. Please go through all of you. I'm giving again 30 seconds. Go through the symbolic form. That's all. It's over, right? There exists T in T. There, no problem. But look at the second part. There, that's the place where all of you should think. What does the statement says? The statement says, I can find a tree in which every leaf is brown. Given a leaf of the tree, it is brown. Given, pick any arbitrary leaf of the tree, it's going to be brown. So what is the second quantifier does? Second quantifier does collect all the leaves of the particular tree, small t. You understand first? That's the main thing. Then you can formulate the statement. Okay. There exists T in T such that for every L in LT, what is the property? The leaf being brown. Already I have drawn picture for you. Okay. Quickly respond. Have you understood this? Very good. Okay. Push up. Let's push up. Very good. I'm happy. Let's see whether you have understood correct. Now negation. Okay, we'll do some 2 or 3 examples today so that we'll consolidate your understanding. Okay. So do not worry. It will come via experience. So what should be the negation? Now it's easy. Once written symbolic form, it's going to be easy. All right. As I said, do layer by layer. Something like peeling onion or cabbage, right? Peel the first layer. Assume knife or vegetable cutter is not given to you. So what will you do? You will try to peel layer by layer, right? So first layer, then second layer. Right. Why only 20? Push. R6 full group has not answered. Only 2. R1 also. Priya, Sanjana. Lot of people are not responding. Now having written symbolic form, it's not tough, right? Okay. Let's ask somebody from R3.
Vinaya.
Negation. The question is about negation. Can you negate in symbolic form?
For all T belongs to.
Very good.
For all
Hmm.
T belongs to T,
Hmm.
there exists
Hmm.
L belongs to LT,
Hmm.
such that
Hmm.
L is not brown.
Very good. Okay. Right. But what is the English meaning? Can I write it in plain English also? Negation in English. Any. What is it? Abhinaya, can you say again? Say in English.
Given a tree in the campus,
Very good. Given a tree in the campus. Hmm.
there is a leaf. There is a leaf which is not brown.
There is a leaf of the tree, right? There is a leaf
Yes,
of that tree. Of the tree. Okay, of the tree, which is
not brown.
not brown. That's what is expected, no? See, what is the statement? Can all of you imagine how the picture of the negation should be? Fantastic. Very good, Abhinaya. So, how the picture of negation should be? Can all of you imagine? This is the situation for forward arm. So, here, if this is false, then what should happen? I should draw the same trees somewhere here. I am drawing here. Okay. I am drawing same all the 3 trees. Bottom also 3 trees. Now what should happen? Okay. There is a leaf of the tree which is not brown. Okay. That means, okay, here it could be, everything should be this. But for this tree also, I should be able to find a leaf which is brown. Somewhere here. Okay. Anywhere, it doesn't matter. So here also, for this tree also, at one place it should be brown. Others it could be green. For this tree also, what should happen? At least one leaf it should be brown. Okay. Is this fine? Have you understood? I'm clearing the feedback. Have you understood? Very good. Okay, let's formulate a similar kind of statement. Okay. There is a page in this book, the book in which every line is printed in purple. There is a page in the book in which every line is printed in purple. This is my statement. Okay, let's clear the feedback. Okay, now all of you know what we should do. This is the statement in English form. Now we should write SS. So before writing SS, we have to identify the quantifiers and the underlying sets. Can you do it now? I'll give 30 seconds. Very good. Let's ask somebody from R9.
Ilandeshwari.
There exist.
Very good. No, first you write down all the sets. You say only the sets. So very good. Quantifiers are there exist for all, right? Very good.
Yes,
I
sir.
understand. So now can you say the quantifier, sorry, underlying set for the first quantifier?
Set of all pages in that book.
Very good. So we will keep P for that, right? Pages P. P is what? Set of pages of the book. Very good. Okay, this is for the first quantifier. There exists. Okay. For the second quantifier, first quantifier. For the second quantifier,
For all
is the second quantifier. And what is the underlying set?
set of all printed lines.
Very like set of all lines of what? That's where you have to keep track.
Lines in
carefully.
that book.
All lines in that book, then it's not right. Let's ask someone else. R8, Krishnamurthy.
Sir, set of all lines in the page of the book.
Page small p. Okay. So given p in p, I have to say what. So what is the notation you want to give? Krishnamurthy, can you tell what is the notation I have to give?
Sir, L, sir.
Yeah, L. Not L. That's where you have to be very careful. Of that way, I'm going to LP. That's good. LP is what? Set of lines on the page P. Very good. Okay. Now I'm clearing the feedback. Again, 20 seconds time for you to write down the statement in symbolic form. First, write, all of you write in your mind. Be ready with that. If you are through, put yes. Again, if you have doubt, you put no. You can always call. If you concentrate, you will be able to answer easily. Please concentrate here. The question is very simple. There is a page in the book in which every line is printed in purple. Already, you have identified quantifiers. There exists for all. For the first quantifier, the underlying set is P, set of pages of the book. For the second quantifier, given a page is small p, what is the LP? LP is set of all, set of lines on the page P. I have not written lines, it's line. Set of lines. Very good. So let's ask somebody from R5.
Kavipriya.
Yes, sir.
Hmm.
For all P.
No, statement in symbolic form. What is the first quantifier?
Set of pages of the book.
Okay, what is the quantifier? You are telling for all, but what is the quantifier? First quantifier.
Sorry. There exists.
There exists.
P belongs to P.
Very good. With what property?
For all. For L.
Line. L
belongs to LP.
Very good.
L is purple.
Printed in purple. Very good. Excellent. That's what you can do. See, the thing is, you have to believe yourselves. Okay, right. Very good. See, you have answered very nicely. Right. Now let's look at negation in symbolic form. Can all of you again go through, think quickly. Let's see whether the time we are improving our time. Very good. That's very good. Somebody from R2?
Ansuya?
So symbolic form for English statement is for every P belongs to capital P. There exists L belongs to LP such that L is not printed in purple.
Very good. Not printed in purple. Again, all of you can, I want you to imagine, okay? I'm not going to draw pages and lines. Yeah, that should immediately come to you. You should see lines, okay? Purple color somewhere, okay? Immediately it should be there. Very good. So can you make your English thing itself? Okay, do it during discussion hour, okay? Negation in English form. Just you have tried that, given a page P, there is a line of that page which is not printed in purple, okay? Very good. Good. Okay. Let's do, yeah. Let's look at the following example, okay? Now I'm going to take a subset of R, set of real numbers, and I'm going to fix alpha as a real number. Okay, these two are fixed. Now, okay, set of real numbers, we always draw with a line. Okay, right. Now I will mark alpha somewhere here. Okay, now I want to say alpha is an upper bound for A. Alpha is an upper bound for A, for the set A. If so, the members of A. So how does the members of A? Where should be the members of A? The member alpha. I'm saying upper bound. It's something like saying, okay, like our father giving, right? This month, your upper or this day packet money upper bound is 100 rupees, something like that. 500, something like, okay. Or this Deepavali purchase, okay. Dress purchase, upper bound is 1000. Within that, you have to purchase the dress. So, how much you will spend? Do we spend 500? Okay, no. Everyone will show the bill of, right? Will you spend 999? No. You will spend till 1000. Okay, that's right. Where the members of A should be something like upper bound. Upper bound means I cannot cross. Okay, this, but I can spend till this. Okay, so where the members of A should be, to the right or left? To the right or left of alpha? Quick, answer this question. Very good. I want very quick response. R7, Abhirami.
To the left of alpha.
Very good. So is it for one? Is there a quantifier in the statement?
Yes, sir.
Which one?
Sir, I think that
every member of A, correct?
Yeah.
Is to the left of alpha. By that, what do I mean?
For all.
Yeah, left of alpha. Yeah. So let's call, if X is a member of A, or simply I'll write X belongs to A, then what is the relation between X and alpha? X will be here, right? So what's the relation between X and alpha? You can answer now quickly.
X is less than alpha.
Very good. But upper bound, should I allow alpha also?
Strictly
Right,
less
no?
than.
Why strictly less than? I will allow 1000 bound means I will spend 1000, right? Right? Less than or equal to, I will allow. Okay, its definition, it's about you. You can put a condition No strict, but I am lenient. Spend till 1,000, but don't show 1,001 bill to me. Okay. If the dress goes 1,010, no, I am not going to allow. Only 1,000 is allowed. Okay. Right. Very good. See, this is our rough understanding. Okay. Given any member of A, it should be to the left of alpha. Every member of A should be to the left of alpha. Okay. Now, can all of you think of what should be the symbolic form of this definition? Alpha is the upper bound of A, F. Can all of you think of this in symbolic form? Quick, already we have formulated it. Should not take time. I thought you will answer quickly. So is there a quantifier? Yes. Already we have identified that quantifier also. Just you have to think and tell the statement. Okay. It should not take time. You should push yourselves. Yeah, somebody from R3. R3. Hepzibah.
Further exists.
I'm not asking negation. I'm asking the definition itself. So I'm going to rewrite it. Alpha is an upper bound of A. If. Do you want to say there exists? I want to fill in these blanks. Okay. Hepzibah, do not worry. Don't worry about making mistakes. You should think and then ponder over it. Already we have identified, right? So what is the right quantifier?
For all.
So you say. That's all. That's only a small. Yeah. That's a mistake. Hereafter you will not do. Okay. For all. Hepzibah, continue. Is there a problem? Network problem? Some problem with your thing? I think she has some problem, right? Some network thing. Okay, let's go to and ask somebody from R6. But why R6 response is poor? Rahul? Rahul, quick.
Sir, for all A is a subset of capital R.
R, no, not R. It is only about the property of A. Alpha is upper bound for A. If every member, already we have written, no, every member, if X is a member of A, then X less than or equal to alpha. This is the property we have already observed. So how do I write it as a statement? For all X, what is the underlying set? Not R. For every X in A, what is the property?
X is less than or equal to alpha.
That's all. Absolutely, that's all. See? Formulating. See, we have understood the definition. Formulating the definition itself takes time. Identifying the quantifier correctly and then pinpointing the relationship. Very good. Okay. When alpha is not an upper bound of A, see, alpha, A, these two things are fixed. Okay. F dash. I hope now it's very easy for you. For this also only 11. I thought before I'm writing, it should be, there should be 40 answers ready. Still that concentration part is weak. Yeah, okay. Let's go to R6. And did I ask now in R6? Okay, then let's go to R9.
Malati.
X belongs to A. X greater than alpha.
X is greater than alpha. Very good. This is the meaning of saying Alpha is not the upper bound of A. Okay, right. Now again, let's do this. A subset of R. Okay. Beta is a real number. Now, can one of you quickly formulate when beta is a lower bound for A? See, A, B are fixed. So, fix A subset of R and beta in R. These two things are fixed. So, beta is a lower bound for A, F. I hope all of you will be ready directly with symbolic form. But anyway, try to imagine again. So, imagine in your mind real line, put a beta and where the members of A should be. Very good. Should I clear the feedback? Yeah, I'll clear it again. Now respond. If you are ready, respond quickly. Somebody is having doubt or only 35. Okay, too much of time I have given. Now it is R8. Somebody from R8.
Latifa Tasneem.
Yes, sir.
Ah.
For
Right.
all x belongs to A,
Ah.
x is
Ah.
greater than or equal to beta.
Excellent. Very good. So don't be nervous. You are excellent. I hope all of you have imagined beta is there here. Members of A should be to the right. Could be equal to beta also. That's allowed, lower bound. Okay. Right. Very good. When beta is not a lower bound of A, I think now it should be fast. I'm clearing all the feedback. Quick. Very good. Okay, quick. Push, push, push. I'm waiting for others. R7, Abhirami, you have not still answered. Tamil R6, still you are not answering. Tamil R6, Tamil How about R4, Magarasi?
Sir,
Hmm.
beta is not a lower bound for A if there exists x belongs to A, x less than beta.
But you have not responded there.
Sir, I respond, sir.
But I couldn't see, no. There is no tick, nothing. Don't do it fast. Now make a tick. I want to see. Ah, that's fine. Good. Very good. I'm clearing all feedback. Okay. Just to make sure whether you have understood, we'll ask this question. Okay. Now A is this set for me. Set of all real numbers which are less than 1. Okay. Can you give an upper bound for this set quickly? Very good. R7 Kalishwari.
So 0.
0 is an upper bound for this set. Did you imagine this set? Have you drawn it in your mind?
Yes, sir.
What are all the elements of this set? I will mark 1. The elements are to the left of 1. I am asking to give an upper bound for this set. Can you correct yourself? Kalishwari, quick.
Sir, 0.9.
No. Upper bound. See, 0.9 would be here and 1 is here. Lot of elements are greater than 0.9, right? Can it happen? Upper bound means the members, every member of the set should be less than this, no? Do you understand? There is a problem. If you say
Yes.
0.99 also problem, because there is a gap. 99 is 99 by 100. Still there are a lot of numbers. Plenty of numbers in between 0.99 and 1.
1, sir.
Yes. So therefore, what is an upper bound? Correct upper bound.
1.
1. Can you give one more upper bound? Okay, very good. 1 is an upper bound. That's correct. Because the definition says, take any element A of A. If A belongs to A, the definition of the set itself says A is less than 1, right?
Yes, sir.
Less than 1 means less than or equal to 1 is also true. That we have discussed. Therefore, we have satisfied the definition. So 1 is an upper bound. I hope all of you have understood. I am clearing all feedback. Very good. Okay. See, this thing, if I start doing it, then it will be like real analysis class. So I'm going to stop here, but take it to the discussion hour, ponder over all the questions. Now she said 0 is a, okay, 0 is there. I said some argument, okay. Is 0 is an upper bound? I said no. 0.99 also not an upper bound. But try to prove it. I have to prove because now I have a definition. Not an upper bound. So therefore, what should I do? I should get an element which is greater than that. Think about this and do. Okay, we will not do it here. See, to make us think of how definitions are coming using quantifiers, we are giving it here. Okay, let's make one more definition. Likewise, identify sets. Identify sets. Okay, examples. Just I want to give examples of sets. Examples of sets with the lower bound. Okay, there also discuss. Okay. Now let's keep A subset of R. We want to say A is bounded above in R. Bounded above in R. If there is an upper bound for A. So how I'm going to write? See, suppose if I say this, if there is an upper bound for A in R. Okay. Now, can you make this definition itself symbolic? Think, all of you think A is bounded above in R if I have to write the remaining things in symbolic form. Okay. How should I write it? I'm clearing all your feedback. Is there a quantifier for that statement? First identify. In fact, that's enough. Just find out whether there is a quantifier. Quick. Quick. My question is very easy. Is there if there is an upper bound for A in R, is there a quantifier? If so, identify what quantifier it is. Why now? The response is slow. R2. Somebody from R2. In fact, I will ask somebody who has not responded at all. Dhanraj Prasanna. Dhanraj Prasanna.
Yes, sir.
What happened to you? Can't you identify the this thing? There is an.
He is answering.
There exists.
Okay, I couldn't hear you. He said there exists, right?
Yes.
Very good. There exists. That's all. But why you people are not responding? That I don't know. There exists an upper bound. We'll call alpha. Okay, there exists alpha. Where? What is the underlying set? There exists an upper bound for A in R. Okay, that means there exists. Now, see, these are all plain English statement. Now we want to make it very precise. So there exists alpha in R. This is the place where we get the upper bound in R only. I'm looking for with some property. What is the property? Quick. What is that I have to write in the bracket? Quick. There exists a element alpha in R with some property. What is the property? Oh. Yeah, somebody from R6. Lekha Shri. Oh, Lekha Shri is R5, right? R6 Deepika.
Sir.
Deepika?
Yes, sir.
Please answer. Just you can answer. If I can find an upper bound for A, right? That's all. If there is a real number, which is a, this is what you got
not
right.
an upper bound.
No, I'm not clear with what you are saying. Okay, let's ask someone else.
Ramya.
Yeah.
Sir, alpha is less than or equal
No,
to
nothing.
A.
I don't want any extra thing. Alpha is a, just write in plain English.
Upper bound for A.
And that's all. I don't want you to expand. Okay, alpha is a upper bound
Upper
for
bound.
A. That's enough for me. Have you understood this? I'm clearing all your feedback. My question is very simple. You are thinking complicated. Very good. When A is not bounded above in R, F, I'm clearing all the feedback. Very good. R9. Somebody from R9.
Kubendran.
For all alpha belongs to R,
Very good.
alpha is not an upper bound for A.
Okay, very good. That's all. Okay. Now let's again do. We will expand the second bracket. Okay. A is bounded above in R if we have there exists alpha in R. Okay, with what property? Alpha is an upper bound for A. But what is the definition for that? When do I say alpha is an upper bound for A? Already I have written in symbolic form. Okay, we'll write this here, right? So, given English thing, so alpha is upper bound means given any element of A, x of A, what is the property? X is less than or equal to alpha, right? That's how I should think. Okay, anyway. See, I don't want this. This is better to keep it like this so that whenever asked, I know definition of upper bound. I can always expand this. Anyway, let's now check. See, now we have two quantifiers naturally. Okay. Now, can one of you negate? Quick. When A is not bounded above? Negation. Yep. Quick. I want to see how many of you can push. Yeah, R4. Somebody from R4. Kavipriya. Kavipriya is R5, right? Okay, R4.
Srinidhi.
Srinidhi.
Sir, A is not bounded above in R if for all X
Very good.
alpha in
A is not bounded. That's how I should say the negation. I should start from the left. Not bounded in above in R if, very good. Start.
For all alpha in R.
Don't say for all, given. Okay, pronounce as given. Okay. For all alpha, given alpha in R, what should happen?
There exists X in A.
Very good.
X is greater than alpha.
Very good. X is greater than alpha. Okay. So formulate breakout rule exercise. Okay. What bounded below? Not bounded below. All those things, do it. Okay. When A is bounded set, A is bounded in R if A is bounded above. I am using short notation now. Bounded above and bounded below, but let's write two statements. A is bounded above and A is bounded below. So what is when A is not bounded subset? Yeah, quick. Again, I want response quick, but I should clear all your feedbacks. Right. Good, very good. Still, quickness. If you are hesitant, you know the answer, but you are hesitant. You know how to think actually, but I don't know why you are hesitant. Yeah, let's go to R1. Rangamati.
A is not bounded above or A is not
Very
bounded
good.
below.
Very good. A is not bounded above or A is not bounded below. If one of them fails, then it will not be bounded. Bounded below. Okay. Very good. Fantastic. Let's go for some other thing. Okay. So that day we talked about when two sets are equal. Okay. Now let's talk about when two real numbers are equal. That also we discussed, right? X equal to Y, if and only if. Let's now discuss when two tuples are equal. Okay. A1 comma A2 equal to B1 comma B2. Okay. If and only if, I'll use this. Can all of you formulate this? Carefully formulate it. Quick. This you have done during your secondary school, 10th standard onwards, right? You have marked points. Ordered pair A1 comma A2. All of you know what I am writing, right? If you have doubt, always you ask me. Put a question mark and ask me. When two ordered pairs are equal, ordered pair A1 comma A2 equal to ordered pair B1 comma B2. Okay, I think a lot of you are having a problem. Let me ask this question. Whether 3 comma 5 is it equal to 5 comma 12? I'm clearing the feedback. If yes, then say yes. If this is equal, put yes. Otherwise, put no. Very good. Okay. Now my question is, next question is whether 3, 5 is it equal to 3, 7? This is my first question. All of you said no, right? Okay. This is my second question. For this, I require an answer. I will clear all the feedback. But why very less? 35 only. Whether these two ordered pairs are equal? Yes. All of you know how to plot these points, right? Okay. This you have done. 2, 3, right? First point, where do I plot? I will again here mark 1, 2, 3, 4, 5. So I will plot 3, 5 somewhere here. Where do I plot 3, 7? I have to mark 6, 7. The point is somewhere else. These 2 points are not equal. This is ordered per 3, 5. This is ordered per 3, 7. Okay. Even though first 2 numbers are equal, second 2 are different. Therefore, this is not equal. This you have answered. Okay. Do you want one more example or now can you answer? I'm not going to ask the other thing. Now can all of you think and answer when ordered per A1, A2 equal to ordered per B1, B2? I thought now response will be fast. Okay, I'll ask one of you. R2, Dhanraj Prasanna.
Sir, if and only if A1 equal to B1 and A2 equal to B2.
Very good. And A2 equal to B2. Excellent. Okay. When are they not equal? Dhanraj, you yourself answer. When A1, A2 not equal to B1, B2. Give some time. Take some 10 seconds so that all of them can think. I think you can now think fast, right? When they are not equal. All of you be ready with your answers. Then Dhanraj will answer. Quick, I want responses. Yeah, Dhanraj, you can answer now.
When A1 not equal to B1 or A2 not equal to B2.
Very good. Okay. Now, that's fine. What do I do for 3 tuples? A1, A2, A3 equal to B1, B2, B3. I should say A1 equal to B1, A2 equal to B2, and A3 equal to B3. Right? Suppose if I have n tuples and say n is 20 lakhs. Okay, I can't put even X, Y, Z and all. That's why I'm using this notation. Okay. Now I don't want to put and or dot and all. So how do I, in saying this, okay, if and only if, okay, I have to form some statement here. First understand, is there a quantifier in saying this? Because look at 2 already you have said. See, the corresponding coordinate should be equal, right? A1 should be equal to B1. This is second coordinate. A2 should be equal to B2. Suppose if I have 10 lakh, okay, or say 100, corresponding coordinate should be equal. 100 times I should write, okay? So better way is to think whether there is a quantifier involved in this statement. Yeah, if so, which quantifier? First identify, is there a quantifier? Quick, response should be fast now. It's nearing time. So we have to, I think we'll complete it. Okay, R8. Somebody from R8? Kaushik? Oh, okay, anyway, R7. Kaushik, answer. Quick.
Yes, sir, for all.
For all. Okay. That's very good. All of you would have thought. But what is the underlying set? That's slightly tricky question. But actually you can answer. What is the underlying set? Can you think of that? See, quantifier already he said. I'm going to write for all. Even I'll make. Now, what is the underlying set for this quantifier? Can you have an English word for this? I'll say that now. Okay. Underlying set is not this A1, A2, but underlying set is something else.
The set of all linear.
Not, that is not correct. That's why, please do not answer Kaushik. Let others think. What is the underlying set? Think carefully. See, he said set of integer, but that's not correct. Natural numbers, okay, you can say, but the thing is, that is also not correct. Why? Because I don't have full natural numbers. What are the quantifier is for what? Subscripts. How many subscripts do I have? I don't have natural number times subscripts. How many subscripts do I have? That's the question you have to think. See, ask questions, no? Each time what you have to do, you have to ask yourself questions. Pertinent question you ask, you will be able to clear. Am I right with the definition? Then again, refer. Okay, can one of you say what the underlying set is now? Quick.
Kubendran?
Ready. I know, better to clear the feedback. Yeah.
Okay.
I'll clear the feedback. Can you now think precisely what is the underlying set? Only 4. Okay, let's ask one of them. Anusia, quick.
Sir, for all n belongs to natural numbers.
That's not right. That's what I said. I don't have full. See, if I have 3 only, look at this. A1, A2, A3 only I'm having. But you are telling natural numbers. Where do natural numbers come to? Natural number means 1, 2, 3, 4, 5, 6. You are having lot of unnecessary things, no? Subscripts for only, quantifier is for this subscripts, right? How many subscripts do you have here? Here, how many do I have?
N subscripts.
Here, how many subscripts? I think
3 subscripts.
3 subscripts. Here also, this is not natural number. This is stopping at here. That's why I said it's 1 lakh or 100 or something like that. Imagine 100. So what is the underlying set? Natural numbers starting from 1 and stopping at
N.
N. This is the underlying set. Okay, 1. Okay. The best way to write is set of natural numbers which are in between. Okay, let me write K, which are in between 1 and N. Or if you want, just write even 1, 2, 3. Same thing as saying 1 dot dot dot. Yeah. Okay. This is a listing. We'll do it later. Anyway, we'll list. This is also listing. Anyway. So, for all I belongs to 1 to N. That is the underlying set. Okay. This property is easier. I think all of you can say it quickly. Quick. Now let's see how quick you are. Because we have overshooted the time. Just 1 minute only we are having. We should finish. Quick. What is the property? So this I will run all those things. 2 n tuples are equal. A1 to an equal to b1 to bn only. For every I from 1 to n, something should happen. What is it? Yeah. Ask someone from R8. Nobody has answered. Yeah, Ashwini.
Sir, AN is equal to BN.
Here I have written I.
So AI is equal to BI.
That's all.
Yes.
Very good. Okay. You do the negation in the classroom discussion. Okay. Negation in breakout room. But before negation and all, try to understand how we have made the statement in symbolic form. How the underlying set we have written in the symbolic form. Okay. Anyway, I'll stop here. Thank you, YouTube audiences.
Yeah, tomorrow we have class.
Yeah.
Yes, YouTube viewers, tomorrow evening we have class.